Welcome! In this series of short videos, we will look at topics for the PowerBasic Windows compiler. Today we will look again at the use of ListViews on Windows forms. This was our application at the end of the last video. We have a single dialog which displays a list view demonstration. This list view has 3 columns, which we've used the inbuilt facilities of the Forms Designer to set up and populate. What we're going to do today is we're going to add some colour to this grid so that each alternate row is a different colour. In addition, we're going to allow the user to sort the grid based on a specific column, either ascending or descending. And finally, we're going to allow the user to select a cell within the grid itself, and we're going to display the data that's held within that cell in the status bar at the bottom of the dialog. So first of all, we're going to do the colouring of the rows. So let's have a look at the code. So to perform this, we're going to do a custom draw inside the callback function, the event handler. So first of all, we're going to set up a custom draw pointer at the beginning of this function. This is using the Windows NMLV custom draw user-defined type. So in order to get this to work, we need to use a notify event, so that when the control is drawn on screen, this sends a notification to our callback function. So now that we have the notify event in place, we need to determine which control on this dialog has actually triggered the notification. So we're going to set up a select case statement. This is using one of the properties of the callback, the NMID, which is our notification ID. This tells us which control has actually triggered the notification. And we're using the case statement to say we're interested in the list view. So now that we know which control has actually triggered this notification, we need to know what kind of notification it is. So we're going to use another select case statement to determine which event type has actually been triggered. So in this case, we're using the NM custom draw. This is where we're going to make use of the pointer we defined at the beginning of this function, by populating it using the CBL param. Now we're going to have to use another select case statement, because of a number of these custom draw events we'll need to handle. First of all, there's the prepaint and the item prepaint events. For these, we're just going to return a constant called notify item draw. But the ones we're really interested in are the item prepaint and the sub-item events. This is where we decide whether the row is to be coloured or not. So we're going to create a little common function called coloured row, which is going to return true or false. True if we want the row coloured, and false if we want to leave it as is. So we will create that function in a moment, but let's push on with the code as it stands. So here are our 2 statements, one for true and one for false. First of all, we will set the colour of the foreground and background. This will be when we want to colour the row. So using our pointer, we can specify the text colour and the background colour. We're using 2 inbuilt values which are constants within PowerBasic, one for the colour black and one for pale green, which was one of the RGB colours. The parameter we're passing to the coloured row is basically the line number. So if coloured row returns true, we will set the background colour to pale green and the colour of the text on that background to be black. Otherwise, we'll keep the background as white and the text as black. So now that we have the event handling in place, let's create this coloured row function. This is a very straightforward function. This takes a single parameter, which is the row number. And we're using the modulus function to work out whether the division of the row number by 2 gives a remainder of 0 or not. If it gives a remainder of 0, we're then going to return true, which will colour the row. Otherwise, we will leave the row with its original colour. So let's try running this code now and see what we get. And there we have our grid on screen. As you can see, alternate rows are different colours. This makes it much easier to identify information within the grid. So now that we've got the rows coloured, what can we do about sorting the columns? Let's drop back into the code. If we go back to the callback function, we're going to put another case statement in here. Where we've defined an event for custom draw, we're going to define an event for clicking on the column header. This will allow us to pick up the fact that the user has clicked on the column header. And in order to make use of this, we're going to create another local variable. This is going to be a user-defined type, which is nm_ListView. And we're going to use the typeset command to populate that variable, using another inbuilt function, cb_nhhdr$, which is the headers. And this takes a single parameter, which in this case we're returning the size of LV data. So next we need to determine whether this is going to be an ascending sort or a descending sort. One easy way of doing this is toggling between ascending and descending. So when you click initially, it will sort one way, and when you click again, it will sort in the opposite direction. So we're going to create a local variable called sortDirection, and we're going to use the XOR command, so we will toggle this. So each time the code passes through here, it will swap from true to false. So we will declare this new variable at the top of our function, and we will mark this one as static. A static variable within a function maintains its value between calls to the function. So basically it remembers the value. So having got that in place, we merely have to test the value of the sortDirection variable. Is it ascending or is it descending? The inbuilt ListView command has a sort option, and that's what we're going to be using. ListView sort takes a number of parameters. The first being the dialog handle, the next being the control handle of the grid itself, and then the last two parameters are the column number and is it going to be ascending or descending. We're using the LV data sub-item plus 1, as the LV data counts from 0. And ListView expects the first column to be column number 1. And for sorting descending, it's exactly the same thing, only with a different parameter on the end. So using this single line of code, we should now be able to sort the column. So let's try running the code now. So there we have our data. So if we click on the column heading of column 3, we will see that it sorts quite happily. It is of course sorting alphabetically. So apart from the last part of the string being a number, it is sorting in alphabetic order. So 1 appears before 10 and 19 appears before 2. So we can click on each column and it will reverse the sort order each time you click on it. If you have a look at the PowerBasic help, you'll see that there are other options other than just ascend or descend. This last parameter is a comma-delimited option list. So these can be cumulative. So you can set it to be ascending, ucase, in which case it's alphanumeric data, but the casing of the character is not significant. Or if one of your columns is entirely numeric, you can use ascend, numeric. And that way it will sort them in numeric order. And the final option is a date sort format, where you can set it to be a number of different types of date format. So this gives you quite a bit of flexibility using this single sort command. So now that we've done 2 of the tasks for this video, the final task will be to pick up the cell within the grid that the user has actually clicked upon. As you will see at the moment in the grid, when a user clicks on a row, the entire row is selected. The reason for this can be seen where we set the list view up. If we have a look at the function where the list view is defined and added to the dialog, we will see that there are in fact no options defined. But if we have a look inside the sample list view function, we'll see we're getting the style into this style variable, and then we're adding 2 additional options, a full row select and grid lines. So we're going to change these options slightly to allow us to do clicking on one cell. We've now added one click activate and single row. If we run the application now, we will see that the grid will be displayed, but when you select on the first column, just the one cell is selected. However, when we select any of the other columns, nothing is being selected. So there's a little bit more work we need to do. So if we hit the F2 button, go back to our list of functions and go back into the callback function, the event handler. What we're going to do in here is we're going to subclass the ListView control. This will allow us to receive extra events that we cannot do within here. So in order to do that, I'm going to declare a couple of local variables to make life a little easier for us. I'm going to create one variable called old ListView proc. This will be the address of the callback procedure that the ListView has been set up with. This will allow us to toggle between the old and the new callback procedures. I'm also going to create two globals, one for rows and one for columns. At the moment, the number of rows and columns in the grid is actually hard-coded. As we will see in here, there are the columns and the rows in hard coding. So we're going to change that slightly and set them up as values in these global variables. This will allow us to access these values later on in the code. So in the callback function, in the initialize dialog event, we're going to set up this subclassing. This is using a Windows API call called setWindowLongW. And the output from this function we're storing in the long old LV proc variable we have just set up. So if we have a look at the parameters, it's using another Windows API call, getDialogItem, taking two parameters, the dialog handle and the handle of the control. This function turns these two values into a single value that the Windows API can make sense of. We're then using a constant, GWLWinProc, and we're using a code pointer to our LVProc function, which we have not yet created. This will be the callback function for the functionality we want to put into our ListView control. Since you may use this functionality in your application, which could have many forms, it's always good practice to use a wm-destroy event to restore the ListView control's original callback procedure when the form is destroyed. Even if you don't actually have to use this, as you have a single dialog application, it's always good practice to have it in your code. This calls the same function again, but this time we're passing it the handle of the old ListView callback function. So with that in place, let's now go and create the new LVProc function. This is taking the four parameters we're passing from the initialize dialog event in the main callback function. And in here, we're going to set up a number of local variables. This will allow us to keep track of things like the column and row number, the number of rows per page, and our ability for picking up mouse clicks on the list view. And finally, a variable to hold the data we're going to pull out of the cell that the user has actually clicked on. Much of the code I'm about to put in here has been borrowed from the code within the demo section of PowerBasic for ListViews. So it saves having to recode this yourself, as it does the job quite nicely. So the first task is to pick up the coordinates X and Y of the mouse when the left mouse button has been clicked. This is triggered by the L button down event. So having got the X and Y coordinates, we're now looking to see if there's a ListView item and sub-item at these coordinates, using the send message W. So if that returns something other than a -1, then we are indeed clicking on a ListView. Otherwise, we can ignore the mouse click. And we're going to call a new function we're going to make big use of called updateLVSelect. We will create that function in a moment. We're going to be calling this function multiple times within this particular function. But the purpose of this function is to return the row and the column that the user has actually clicked upon, so we can actually pick up the data within that cell using the ListView getText command. And this populates the str data variable. In order to see what the user's clicked on, we're going to go back to our dialog and we're going to add a status bar control to the bottom of the dialog. So we'll come back to this function in a moment, but let's pop into where the dialog is actually defined, and we'll put in our status bar. And there is the status bar. We don't need to specify any coordinates for the status bar, as in this case it will automatically go to the bottom of the dialog. And as we've added a new constant, we need to define this at the beginning of our code. And there is our new constant. So we can now go back to the function we were building up. And I'm going to use a control set text to set up the text in our status bar to report on the row number, the column number, and the data found within that cell. So now that we've handled this specific message, we can then return a 0 and not call the original ListView callback. This avoids events being triggered twice. And the other piece of code I'm going to paste in here is straight from the sample section. This is to pick up where the user is using the keyboard rather than the mouse to move around. This is using the key down event. We're looking for a number of different things here, the up, down, right and left buttons on the keyboard, each time calling this new function we have yet to create, update LV select, and also it handles page up, page down, home and end. And as we did before, we're passing back the value 0 to say that we've handled this message and we do not want to call the original ListView callback function. So now with all that code in place, we need to create the new update LV select function. So this particular subroutine is taken straight from the samples that ship with PowerBasic or ListView controls. And again, what this is actually doing is looking to see what row number the user has actually selected. The important parts in here is it's using the ListView unselect to ensure that anything previously selected is unselected on screen. And then it's using the ListView select command to highlight on screen the cell that the user has actually selected. And the very last piece of code within this subroutine is ListView visible. This ensures that the cell that the user has clicked on is actually visible on screen. In this particular case, this is probably unnecessary, because the user themselves has clicked on the cell, therefore the user can already see it. However, the ListView visible command is very useful. If you have a list view as a grid displayed to the user on screen, containing many items. If the user is doing a search on that grid to find a particular item, the item they are searching for may not be visible on the screen. However, once you've located where it exists within the grid, you can use ListView visible to automatically scroll the data in the grid to make the selection visible to the user. So we'll leave this line of code in here. So if we save our application now and try running it once more. So we can see our grid is displayed on screen. We have our status bar at the bottom of the dialog. If the user clicks on the first column, first row, it will display row number 1, column number 1, and the data coming out of that is column 1, row 1. If we try, for example, column number 3, it's picking up the fact that we have indeed clicked on column number 3, and it's pulling the information out of that cell quite happily. If we pick a row further down the grid, it's pulling out row 10, and it's going for column number 3, which we've clicked on. To prove this is working correctly, we will click on a column header so that the row is now sorted. So that the entry down here that says column 3, row 20, is in fact now column 3 but row 13, but it's still pulling the right information out. So we can now quite happily select any of the rows and columns, and the value appears down in the status bar. However, when we sort the column, we will see the value is obviously still highlighted, but if you click on another cell, the original cell is not de-highlighted. It is not unselected. And the same problem would be there for possibly 3 columns. So when we resort the column, either ascending or descending, we should unselect all the values the user has selected, and we will blank out the entry in the status bar. So we'll need to pop back to the code, and we're going to create a little function whose job it will be to perform that function. So in our callback function where we're doing the sorting, immediately the sort has completed, we will call a new function called deselectAll. This will take two parameters, the handle of the dialog and the handle of the list view. And finally, we will use a control-set-text command to blank out the status bar. So this function to deselect all entries in the list box is going to be very straightforward and basically just a for next loop, looping through each of the rows and each of the columns, using the global we've set up previously to define how many rows and columns the list view actually has. And we'll be using the ListView unselect command to unselect any entry that's been selected in that row and column. So if we run that code now, we can quite happily select any of the entries in the grid, and if we sort it, we will see that the previous entry is no longer there, and the value in the status bar has been blanked out. So what we've achieved today are three things. First of all, we've added some colour to our list view to make each alternate row a different colour. We've additionally allowed the user to sort the entire grid based on one of the columns, either ascending or descending. And finally, we've allowed the user to click on a single cell within the list view grid. And we have displayed both the row and the column number that the user has clicked on, plus the data held within that grid. In the next video in this series, we'll be making our code a little more generic to allow us to load, for example, a CSV file directly into a list view control, acting as a simple grid. However, that's it for today. Thank you for watching.